Today is going to be a different kind of video. I recently was in a speech writing contest and one of the questions caught my eye. So here you go. How feasible is space travel? Now, we all love the idea of humans reaching another planet and being able to travel in space, both in our solar system and outside. But if we get out of the fantasy and take a step back and look at the idea as a whole, well, we get one major question. How feasible is space travel? Is it really science fiction? Or can it someday be science fact? But what exactly does how feasible is space travel mean? Does it mean in our solar system? Because if so, it certainly is, and we've already done it. I mean, we landed on the moon about 50 years ago, so I took the idea as the feasibility of interstellar travel and solar travel being very common. And with this in my mind, I researched the idea. Well, to make it easier, I dissected the idea into three separate categories: the technology, the economics, and the human aspect. Each of these are the only way we would achieve space travel being feasible. So, question number one. Is it actually possible? And by that I mean, do we have the technology to do this? Well, the answer is simply yes. There are two options down this route: faster than light travel or slower than light speed. But faster than light is highly unlikely, so sadly no hyperdrive for us. I decided to go with slower than light speed. And in a rocket that goes at an average of 13,500 kilometers a second, it only takes us a week or so to reach the moon, a few years to reach Mars, and the next star, well, that's only a century. There's the problem. We have to make it within a human lifespan to make it feasible. So, if we create a rocket that accelerates at 1g, 10 meters a second, we would reach Alpha Centauri in 5.5 years. That may sound daunting, like that's one fast rocket. But the fastest rocket we've made goes at 210,000 kilometers an hour, which is well beyond 1g. It's a lot of g's. So, we can actually do that. But another problem is, how do we fuel the rocket? Well, Ryan Weed, an antimatter physicist, has developed a machine to harness the power of antimatter and use it as propulsion, which would be a much easier resource to use, as you would need a lot less of it in comparison to fossil fuel. We must certainly have the technology, but these things are awfully expensive. How do companies justify such expeditions? Well, the asteroids in the asteroid belts have many trillions of dollars of resources on them, and the amount of platinum, plutonium, and gold, and other precious metals in space, which would be worth much more than it would cost to do the mining operations. And with the amount of helium-3 on the moon, you can make much safer nuclear reactors as an alternative fueling method if the whole antimatter thing doesn't work out. We could also commercialize space by the 2030s. As the Orbital Assembly Corporation planned to put the Voyager space station into space by 2027, which, subtle flex, I drew up plans for it 3 years ago. By accident. NASA definitely has tabs on me. This would be the first commercialized space hotel, and this would make the final frontier the most profitable frontier for businesses. Now, with that off the list, we go on to the final and most problematic point, the human aspect. Now, you may be wondering what I mean by the human aspect. Well, none of this can be done without people. People to invent the technology, invest in the businesses, and be mad enough to go on these possibly one-way trips. And who'd be willing to take these risks? Well, we already have. People are volunteering to go to Mars, so it's not unlikely, as our species has been exploring for millennia. We sailed the oceans that were deemed unsailable, and when we were done with that, we went to space. This is just the next step in our exploration. But we have one major problem: the wait theory. This theory is that people will always wait as long as technology is advancing, since people will think that later on we will have better and faster technology. For example, if people send a generation ship to Alpha Centauri at slow enough speeds, nowhere near the percent at the speed of light, it would take them about 6,000 years, and after the 60th generations of humans, they would land on the planet, only to figure out it had already been colonized, because about 1,000 years into their journey, a man had invented a much quicker way to travel. And the people who had been sent to the planet in one lifetime, instead of 60, had already colonized it, and the generation ship's trip had been for nothing. Because of that, people are hesitant to go on these expeditions because they feel their sacrifices will be in vain. But with that idea in mind, no time is the best time. And to me, that shows that we need to start now, or we never will. As I pointed out, we really do not have a better time to start. Technology is perfect, the economy is good enough to handle this, and people are willing to go. And it isn't just for the sake of humanity's expansion. Just think about all the technology we invented and got out of the space race. Nylon, fireproof suits, internet, and GPS, just to name a few. Imagine the sheer amount of technology we would get from a project 20 times bigger. It would revolutionize the world, and we'd have to develop more efficient farming for the colonies, and then we could use these on Earth to help solve hunger. As space stations becoming more common, it would help with overpopulation. It would solve many world problems. I believe that space travel is not only feasible, but necessary. I believe we must begin a new age, the second age of exploration, the age of space exploration. Thanks for watching. So that was a very different type of video. I just felt like doing something else. I didn't have I didn't have anything prepared, so I just, rewrote the script, made it more better for YouTube. If you enjoyed it, like and subscribe and all that good stuff. Thanks for watching. Bye.